Welcome dear students. In this video we are going to learn about integers. Integers, the combined collection of whole numbers and negative numbers, is known as integers. Thus, starting from minus infinity, then going further to right, we get minus 5, minus 4, minus 3, minus 2, minus 1, 0. Then 1, 2, 3, 4, 5 and continues to infinity are integers. Integers help us in distinguishing numbers above 0 and numbers below 0. At times, we are required to use numbers less than 0, that is, numbers with a negative sign. These numbers are marked to the left of 0 on number line. For example, these are few situations in which we are required to use negative numbers: temperature, depths, debits, that means withdrawal of money from accounts, borrowings, overdrafts, etc. We know that water freezes at 0 degrees Celsius. When temperature falls further, it is termed as sub-zero, that is below zero temperature. If temperature falls 5 degrees Celsius from 0 degrees Celsius, we write it as minus 5 degree Celsius. So this is the first example of practical use of negative number. Like 0 degrees Celsius, MSL, the full form of which is mean sea level, is used as a zero reference for heights and depths. If we say a certain mountain peak is 3,500 meter high, it means that it is 3,500 meter above sea level. If we say an underwater rock is 57 meter deep, it means that it is 57 meter below mean sea level, which in other words or mathematically means that its height is minus 57 meter. So minus 57 meter actually means that from mean sea level it is measured downwards instead of upwards. Assume that I have rupees 4,000 in my bank account. I need rupees 5,000. I have less money, but my requirement is more. Therefore, I overdraw my account by rupees 1,000. Overdraw means withdraw money more than the balance available. My balance is 4,000, but I withdraw 5,000. That means I overdraw my account by rupees 1,000. My passbook or my bank statement will show my balance as rupees minus 1,000 because I have taken the money from the bank or I have borrowed money from the bank. Now, if I deposit rupees 7,000 in my account, how much my balance would be? It would be rupees 6,000 because 1,000, which is minus, will be adjusted against the deposit of rupees 7,000. So the bank will take 1,000 from 7,000 back, which I had overdrawn, and my balance would be rupees 6,000. So this is the second example of or third example of use of negative numbers. For managing budgets, earnings are marked as positive and spending is marked as negative. Similarly, in account registers or in companies or in offices, profit really means positive and loss means negative. In coordinate geometry, which you will study in ninth class, x coordinates to the right of the y-axis are taken as positive and to the left of y-axis are taken as negative, and y coordinates above the x-axis are taken as positive and below x-axis are taken as negative. Students who are in 7th or 8th class can skip this slide. Smallest integer is unknown because the smallest integer can go up to minus infinity. Largest integer is also unknown because positive integer can also go up to infinity. Every natural number is also an integer. Every whole number is also an integer. However, every integer is not a natural number or a whole number. For example, -2, -7, -123, etc. are neither natural nor whole numbers. Integers can be shown on a line marked at equidistant points. Equidistant means equally spaced. The distance between any 2 points is equal, as shown in the figure. 0 is marked somewhere in the middle. So 0 is an arbitrary point which can be approximately chosen anywhere on the line. Points to the right of 0 are positive integers marked as +1, +2, +3, etc. or simply 1, 2, 3, etc. That is, the positive sign by convention is not shown. It means if a number appears without any sign, it automatically means that the sign is positive. Points to the left of 0 are negative integers and are marked -1, -2, -3, etc. On a number line, the number increases on moving to the right and decreases as we move to the left. Thus, 5 is greater than 0. Look at the number line. 5 is on the right of 0. So 5 is greater than 0. As 0 is to the right of -6, look at the number line again. -6 is to the left of 0 and 0 is to the right. So 0 is greater than -6. Again, one more example. Compare -3 and -1. Now -3 is less than -1 because -3 is left of -1. We can say that 0 is smaller than every positive integer and greater than every negative integer. 0 is neither a negative integer nor a positive integer. Every positive integer is greater than every negative integer. Any number on the right is greater than any number on its left and vice versa. That goes on to say that any number on the left is smaller than any number on its right. Please memorize these basic facts. Any negative integer is a multiple of -1. That is, every negative integer can be written as a product of the numeral. Numeral means the symbol, the number, or the digit, forming the integer and -1. For example, -3 can be written as -1 into 3. -8 can be written as -1 into 8. -13 can be written as -1 into 13, and minus 1 can be written as minus 1 into 1, and so on. Study the following products. Minus 1 into minus 1 is equal to plus 1. Minus 1 into minus 1 into minus 1 is equal to minus 1. So 3 times minus 1 has come. Again minus 1 into minus 1 into minus 1 into minus 1 is equal to plus 1. Look here, the minus 1 has appeared 4 times. Again minus 1 into minus 1 into minus 1 into minus 1 into minus 1. This time minus 1 has come 5 times and it is equal to minus 1. So we observe that the product is plus 1 when minus 1 is multiplied even number of times, and the product is minus 1 when minus 1 is multiplied odd number of times. In short, we can say that minus 1 raised to power n is equal to plus 1 when n is an even number, and minus 1 raised to power n is equal to minus 1 when n is an odd number. Remember, plus into minus is equal to minus, minus into plus is equal to minus, minus into minus is equal to plus, plus into plus is equal to plus. The bracket, when it is opened, it means it is being multiplied. So plus bracket minus means plus into minus. So let's say we start with some digits now. Plus, if multiplied by a negative integer, that means plus into minus a is equal to minus a. Minus into plus a is equal to minus a. Minus into minus a is equal to plus a is equal to a. And plus into plus a is equal to plus a is equal to a. Let's go further on this. Addition. Plus b plus within bracket plus a. So when you open the bracket, plus into plus is plus. So it is equal to b plus a. Minus b plus within bracket minus a. Again now when you open the bracket, plus into minus is minus. So it becomes minus b minus a. So minus is common, minus comes out. So it becomes minus outside within bracket b plus a. Minus b plus within bracket plus a is equal to minus b plus a. Plus b plus within bracket minus a is equal to b minus a. Please note down these on your notebook and practice them again and again. Here are some examples. So 9 plus within bracket plus 4 is equal to 9 plus 4 is equal to 13. Each example is corresponding to the identity which we have used above. So minus 9 plus within bracket minus 4 is minus 9 minus 4. Minus comes outside, 9 plus 4, 13, so minus 13. Minus 9 plus within bracket plus 4 is minus 9 plus 4, so is equal to minus 5. 9 plus within bracket minus 4 is equal to 9 minus 4 is equal to 5. Adding a positive integer means moving to the right. Now how to remember this? When you are adding positive, you are adding positivity. Remember like that. When you are adding positivity means you are moving towards the right. So your number will move to the right. Let's say example. We have a number as 2. When you add plus 3 to it, when you add 3 to it, so 3 is positive. So 2 plus 3 is equal to 5. So from 2 you shift to 5. And if the integer available is minus, that is minus 2. When you add plus 3 to it, it becomes plus. Again, minus 2 was on the left and plus 1 has moved to the right. So while adding 3 to 2, you get 5, you have moved to the right. While adding 3 to minus 2, you have got 1, again you have moved to the right. Adding a negative integer means moving to the left. Adding negative means adding negativity. Adding negativity means moving to the left. So let's take example 2 plus, you are adding now minus 3. So 2 plus You open the bracket, plus into minus is minus. 2 minus 3 is equal to minus 1. So you have moved from 2 to minus 1, which is to the left. Now you take minus 2 and you add minus 3. So minus 2 plus within bracket minus 3. You open the bracket, plus into minus is minus. So you get minus 2 minus 3, which gives you minus 5. Again you have moved to the left. So adding negative integer is saying that you are moving to the left. Adding positive integer means you are moving to the right on the number line. Subtraction. Plus b minus within bracket plus a is equal to b minus a, minus b minus within bracket minus a is equal to minus b plus a, because when you open the bracket minus minus become plus. Minus b minus within bracket plus a is equal to minus b minus a. Minus comes out common within bracket b plus a. B minus minus a, minus minus become plus, so b plus a. Again we take examples. 9 minus within bracket plus 4 is equal to 9 minus 4 is equal to 5. Minus 9 minus within bracket minus 4 is equal to minus 9 plus 4 is equal to minus 5. Minus 9 minus within bracket plus 4 is equal to minus 9. Minus 4 is equal to minus comes outside common within bracket 9 plus 4 is equal to minus 13. And 9 minus minus 4 minus minus plus, so 9 plus 4 is equal to 13. Please note down these identities and practice them again and again. Subtracting a positive integer means moving to the left. Subtracting means you are adding negative. It means you are adding to the negativity. Adding to the negativity means, subtracting a positive integer means you are taking out the positivity. Taking out the positivity means increasing the negativity. That means moving to the left. So this is just a trick to memorize, that's all, just to imagine. So subtracting a positive integer means moving to the left. Let's take an example. You subtract 3 from 2. So 2 minus 3 is minus 1. So from 2 you have moved to minus 1. You have moved to the left. Now you subtract 3 from minus 2. So you get minus 2 minus 3 is equal to minus 5. Again you have moved from minus 2 to minus 5. You have moved further to the left. Subtracting a negative integer means moving to the right. Why? Because subtracting a negative means you are taking out the negativity. Taking out the negativity means increasing the positivity. Increasing the positivity means moving to the right on the number line. So let us say now, let's take two examples where we are subtracting a negative integer. So you subtract minus 3 from 2. When you subtract minus 3 from 2, you write arithmetically 2 minus within bracket minus 3, minus minus becomes plus, 2 plus 3 you get 5. So you have moved from 2 to 5, that is you have moved to the right. Now you subtract minus 3 from minus 2. So you write minus 2 minus within bracket minus 3, because you are subtracting. So you put the sign minus, but you are subtracting negative 3. So you put minus 3 within bracket. So minus minus become plus when you open the bracket. So it becomes minus 2 plus 3. 3 minus 2 is 1. So what has happened? You have again moved to the right, because you have taken out the negativity. You have subtracted the negative integer. That's why you have reduced the negativity, you have increased the positivity, so you have moved to the right. Multiplication. B into A, that is plus B into plus A is equal to B into A. Minus B into minus A is equal to B into A. Minus minus become plus. Minus B into plus A is equal to minus B into A. B into minus A is equal to minus B into A. Now see the corresponding examples. Plus 9 into plus 4 is 9 into 4, 36. Minus 9 into minus 4 is again 9 into 4 is equal to 36. Minus 9 into plus 4 is minus 36. 9 plus into minus 4 is again minus 36. Division. Plus B divided by plus A is equal to B by A. Minus B divided by minus A is equal to again B by A, because Denominator, numerator both are negative, they will cancel each other out. Minus b upon plus a is equal to minus b upon a. And if denominator is negative, b upon minus a, again it is equal to minus b upon a. Now let's see the corresponding example. 36 divided by 4 is 36 by 4. 4 9 the 36, 9. Minus 36 divided by minus 4, it becomes minus minus get cancelled out. 36 by 4 is equal to 9. Minus 36 divided by 4 is minus within bracket 36 by 4, that is 4 9 the 36, minus 9. Again 36 divided by minus 4 is equal to minus within bracket 36 by 4, 4 9 the 36 is equal to minus 9. Please note down all these operations in your notebook separately and study these examples, and then choose some figures, numbers of your own choice and practice them. There are finite number of integers between any two integers. For example, there are 6 integers between minus 3 and 4. So when you write like this, minus 3, after minus 3 comes minus 2, after minus 2 comes minus 1, after minus 1 comes 0, then 1, then 2, then 3, then 4. So the numbers lying between minus 3 and 4 have been highlighted in red color. And how many are they? 1, 2, 3, 4, 5 and 6. They can also be obtained by taking the difference between the two numbers and subtracting 1 from it. So we subtract 4 minus, what is the other number? Minus 3. So 4 minus within bracket minus 3. Minus minus become plus. So 4 plus 3 is 7. 7 minus 1 is equal to 6. So between minus 3 and 4, there are 6 integers lying in between. And there are 3 integers between minus 1 and minus 5. Now this time I have taken both negative integers. So we write like this, starting from minus 5, minus 4, minus 3, minus 2, minus 1. That is, now minus 1 is a larger number. So minus 1 minus within bracket minus 5, minus minus become plus. So it becomes minus 1 plus 5 minus 1. So minus 1 plus 5 is 4, 4 minus 1 is 3. So there are 3 numbers, minus 4, minus 3, minus 2. Thus, total integers between two integers x and y is equal to x minus y minus 1. If you are called upon to find out the number of integers between any two integers, just take the difference between two integers, subtract the smaller figure from the larger figure, and then subtract 1 from the result. Whatever answer you get, that will be the total number of integers lying between the two given integers. Ascending order. When numbers are written from the smallest to the largest, the order is called ascending. Descending order. When numbers are written from the largest to the smallest, it is known as descending order. For example, minus 34, minus 17, minus 13, minus 5, 0, 3, 7, 13 is ascending order, because minus 34 is the smallest number and 13 is the largest number. So smallest number is written first and largest number is written last. This is the ascending order. And 13, 7, 3, 0, minus 5, minus 13, minus 17, minus 34 is descending order, because the largest number 13 is written first and minus 34, the smallest number, is written last. Predecessor. Number preceding a given number is called its predecessor. It is given by n minus 1. Thus, predecessor of minus 7 is minus 7 minus 1 is equal to minus 8. Because on the number line, minus 8 comes left of minus 7. That means minus 8 precedes minus 7. Successor. Number succeeding a given number is known as its successor. It is given by n plus 1. Thus, successor of minus 14 is minus 14 plus 1 is equal to minus 13, because minus 13 comes after minus 14, that is minus 13 is immediately one point to the right of minus 14 on the number line. Let us recall these 2 points. We studied in the video on natural numbers and whole numbers that every natural number has a successor and every natural number except 1 has a predecessor. That is, the natural number 1 does not have any predecessor. Then every whole number has a successor and every whole number except 0 has a predecessor. That is, whole number 0 does not have any predecessor. But what about integers? About integers, every integer has a successor and every integer has a predecessor. In other words, there is no limitation regarding predecessors for integers. Like in natural number, 1 does not have any predecessor. In whole numbers, 0 does not have any predecessor, but there is no such limitation or condition in the case of integers. Every integer has a successor and every integer has a predecessor. Integers are closed under addition, subtraction, and multiplication. Just try to recall natural numbers and whole numbers which we covered in the previous video. Natural numbers and whole numbers are not closed under subtraction. They are closed only under addition and multiplication. Here is a small change. Integers are closed under addition, they are closed under multiplication, but additionally they are also closed under subtraction. This means that integer plus integer is equal to integer. The operation of integer on two integers will definitely give an integer. Integer minus integer is equal to integer. That is, the operation of subtraction between two integers will yield an integer. And integer into integer is equal to integer. That is, the product of two integers is always an integer. Let us see examples. 4 into 9 is equal to 36, integer. 4 into minus 9 is equal to minus 36, again an integer. Then on the right hand side, minus 4 into minus 9 again is equal to 36. 36 as an integer. Minus 4 into 9 is equal to minus 36. Minus 36 is an integer. 4 plus 5 is equal to 9, integer. Minus 4 plus within bracket minus 5 is equal to minus 9, again an integer. Minus 4 plus 5 is equal to 1, integer. 4 plus minus 5 is equal to minus 1, again an integer. Now let's see the subtraction. 9 minus 4 is equal to 5, integer. Minus 9 minus within bracket minus 4. We have taken the example of positive integers, both negative integers, one positive integer, one negative integer. So minus 9 minus within bracket minus 4 becomes minus 9 plus 4 minus 5, again an integer. So 9 minus within bracket minus 4 becomes 9 plus 4 is equal to 13. Minus 9 minus 4 becomes minus 13, again an integer. So these examples go on to prove that integers are closed under addition, subtraction, and multiplication. But integers are not closed under division. This means that operation of division on integers may not yield an integer. Here are some examples which show us that integers are not closed under division. 3 upon 2 is equal to 1.5. Now 1.5 is not an integer. 1 upon 3 is equal to 0.3333 and it goes on. Again, this number is not an integer. 7 upon 2 is equal to 3.5. 3.5 is not an integer. 3 upon 5 is equal to 0.6. Again, 0.6 is not an integer. So dear students, with this we come to the end of this session. We come to the end of video on integers, and I hope that this video was helpful to you in understanding the definitions, concepts, and facts related to integers. For more videos related to math concepts, education, riddles, puzzles, and Gurbani, do subscribe to this channel. and do remember to like and share the videos as well. Thank you very much. God bless you all. ਤੁਹਾਡਾ ਸਾਰਿਆਂ ਦਾ ਬਹੁਤ ਬਹੁਤ ਧੰਨਵਾਦ। ਰੱਬ ਰਾਖਾ।